Solve using matrices. All right, so this is how I can rewrite this as a matrix. I can take the coefficients 5, -4 for the top row, negative invisible 1 for the bottom row, multiply that to a matrix of x and y, and that will equal what I get over here, -10 and 2. Now, this is basically following that rule that if you watch all of my videos in order, which I pray that you do, if you have something like this where you're trying to find matrix B, so like a matrix times a matrix equals a matrix times a matrix equals a matrix, you inverse A to the left side of both sides, which allows that to cross out. And so what you need to find B is you need B equals the inverse of A times X. So what I need to do is I need to call U A and find the inverse of it. So the inverse is found by taking 1 over the determinant, which is AD minus BC, and you're going to multiply that to the matrix where A and D are flip-flopped and B and C are opposite. So the inverse of A is going to be 1 over A times D, which is 5 times 1, minus B times C, which is -4 times 1. Thankfully, we get 1. D is going to be 1. A is going to be 5. -4 is going to be 4. -1 is going to be 1. So 1 times 1, 4, 1, 5 is just 1, 4, 1, 5. So my inverse matrix is that guy right there. So XY is going to be my inverse matrix times X. So 1, 4, 1, 5 times this guy, -10, 2. Okay, split this up. XY is going to equal 1 times -10. So what is this, a 2 by 2? We're multiplying that to a 2 by 1, so we'll get a 2 by 1 when we're done, so a 2 by 1. So 1 times -10 plus 4 times 8, 1 times -10 plus 5 times 2 is going to end up giving us -2, 0. So X equals -2, Y equals 0. And that's how you can solve a system of equations using matrices. Isn't that neat?